and welcome to our this lesson. And today we are beginning a new topic, volume, capacity and mass. And these are things that we have done in class 7. Just we're going to do a revision of them and maybe increase a few concepts that we are supposed to use. Number one, in volume, we deal with what we call cubes. We also deal with cuboids. So we need to understand what cubes and cuboids are. Now a cube is a shape in which all sides are the same. All sides are equal. A cube has all sides equal. There is no length, there is no breadth, there is no width, there is no height. Then a cuboid is an opposite of that, where you find that some sides are longer compared to the others. So a cuboid is made up of rectangular shapes, rectangular faces, while a cube is made up of square shapes. So this is made up of square faces, and then this one is made up of rectangular shapes, rectangular faces. So that is the difference. If a shape is rectangular, meaning that it has a length and a width. And then when now you make a cuboid, you will have a height, the same here. If it's a cube, it means that there is no length and width, all the sides are equal, and therefore the length, the width, and the height measure the same. So that is very, very important, because we realize that we will be given some questions where you are told that a shape is a cube, or a shape has a square base, and then you ask, given the volume, then you ask about the height. If it's a square base, it means this side and this are equal, so height is not given. So when you multiply this and this is what you call the base area. So we are coming to that. So we want to begin by understanding what we are supposed to do as far as this work is concerned. So volume of cuboids, unit for volume of cuboids, you take length times width times height. That is for cuboids. Or you can talk about length, something they call length, they can say length. Breadth is simply width, then times height. So these are things that you're going to use to be able to get volume of cuboids and cubes. So as I said, in cubes, we don't have length, width and height, or length, breadth and height. All are the same. Again, we are going to look for base area, and we're also going to calculate the cross-section area. The reason why we are going to do this is because these are brought in the exam. Most of the time they will bring that. They tell you the cross-section area or the base area is this, and the height is this. What is the volume? So you must also understand that. So we begin by doing some examples here. Examples. They're given a shape like this. They're telling this 12 centimeter, 8 centimeter, and 6 centimeter. There's cube. What is the volume? So volume will be equal to length times width times height. Our volume then will be equal to the length, 12 centimeter, times the width. The width is 8 centimeter, then times the height, which is 6 centimeter. If you multiply this well, you get 96 times 6, 54. 54 plus 3, 57. So you get 576 centimeters cubed. Remember, volume is given in cubic units, unlike area, which is given in square units. So here you are not going to write centimeters squared. No, you are going to write centimeters cubed. That a small 3 means cubic. Can have cubic centimeters or cubic meters. So it's given in cubic units. Maybe to give you another question. Example 2. A box measures 1 meter. Question. A box measures 1 meter by 1 meter by 1 meter. Definitely this is a cube because all the sides are equal. Then question A, what is what is measures in centimeters? What is its measures in centimeters? It is not in centimeters squared, it is in centimeters. So you just change this to centimeters. So its measures in centimeters is 100 centimeter by 100 centimeters by 100 centimeters. But you can't write 100 centimeter. No. You have been asked the measures. Measures means the 3 sides, not one side. Then B, they're asking, what is its volume in cubic centimeter? What is its volume in A, cubic centimeter, and B, cubic meters? So this is what you're supposed to do. The reason why they ask you to change this because they knew they will ask you the question there and this question will be here. So we don't need to change another time more. So you just take that. A, that is Roman 1, in cubic centimeters, how do you get volume? You multiply the 3 sides. So 100 centimeter times 100 centimeter times 100 centimeter. That will give you 1 million cubic centimeters. That will be volume in cubic centimeters. Roman 2, the volume in meters cubed or cubic meters. 1 meter by 1 meter by 1 meter. That will give you 1 cubic meter. Simple as that. So I want to give you another question where you are given maybe the volume and some of the measurements, but you are not given part of the measurements. Like for example, you are given that the length of some shapes here is length 0.6 meters. Then you are given the width is not given, which they are calling breadth. In this case, breadth is not given, and then they are giving the height. The height is given as 1.1 meters, and then the volume is given as 0.594. Volume 0.594, and these are cubic meters. So now, whenever you are given a question like this, it's very easy for you to calculate this question. So because you have seen its length and breadth, automatically this is not a cube, it's a cuboid. And so you say volume of a cuboid is equal to length times breadth times height. So the volume is given. Remember I told you, if you analyze a question like this, it's likely for you to be able to know what is given and what is not given. So volume is given. So where there is V, you replace with this one. So 0.594 is equivalent to, the length is given 0.6 meters times, the width is not given, so you can just write width times the height is given 1.1. So that you multiply 0.6 times W times 1.1, that will give you 0. There are 2 decimal places, 1, 2. 0.66 W is equals to 0.594. So we don't want 0.66 W, we want 1 W. So you divide by the coefficient of W. Coefficient is the number that appears before the W, over 0.66. So in this case, you will have 0.594 over 0.66 is equals to W. Here in this case, we remain with W on that side alone. So in this case, now you look at this one. Yeah, 1, 2, 3 decimal places, 1, 2. So you multiply with the highest number of decimal places. There are 3. So here 3, here 2. So you multiply by 1,000 by 1,000. If you multiply by 1,000, the 3 decimal places will be removed by the 3 zeros, and you remain with 594 over. This will be 66. Then 2 decimal places. One will bring it there, another one will bring it there. It becomes 66. Then you add this 0 over 660. So from there, you can be able to simplify. So by 2, 330. By 2, 2. For 4, 19. 9 for 18. Then 14, 7. By 3, 11, 110. By 3, 9 for 27. 9 for 27. By 11, 10. By 11, 9. So you get 9 over 10. But because these answers are not given in fraction, you must change this into a decimal. So 9 over 10 is simply 0.9. So 0.9 meters. Our wind, in this case, is equals to 0.9 meters. So that is what you're supposed to do, learner. So another thing you notice here is that in a question, if the question is all about decimals, you are not supposed to give your answer in fraction unless you advise that. But if you are not advised to do that, then you must leave your answer as a decimal. So that's exactly how you do it. Maybe you take a second example which is technical. That will be how many 60 cubic centimeters cubes can be packed into a rectangular box measuring 3 meters by 2 meters by 1 meter by 20 centimeters. So this is given as now let me draw this here, because it's important that you see what I'm supposed to do here. You are told that the rectangular box measures 3 meters. That is to be length, and then 2 meters and 2 meters 40 centimeters, 2 meters 40 centimeters, and this one is 1 meter 20 centimeters. That is the height. The question is how many 60 cubic centimeters cubes that how many 60 cubic centimeters cubes. In other words, they're asking if someone has some cubes whose volume are 60 centimeters cubed, how many of them can enter into this particular box? Now in that case, remember what we call volume. Volume is the amount of space occupied by a substance, the amount of space. So how many of these will get into this box? If you can see our measurements here are in meters and centimeters. And look at what's supposed to enter here is in terms of centimeters cubed, meaning that we have to change all these into centimeters so that they appear the same unit as that one of the cubes to enter here. So this is 2 meters 40 centimeters. 2 meters is times 100, you get 200 centimeters plus 40. So in this case, our wind is going to appear 240 centimeters. Remember, we are changing. This is 3 meters times 100. It's going to give 300 centimeters. And this one is 1 meter, then plus 20. This is going to be 120 centimeters. So after changing like that, you get the volume of this, then divide by the volume of that one particular cube, because one is 60 cubic centimeters. So we are going to say volume is equals to length times width times height. In this case, our volume will be the length 300 centimeter times 240 centimeter times 120 centimeter, in which it will give you this 72 times 12, 4, 14, 2, 7, 4, 6, 8. So this is going to give you a volume of 864, then 1, 2, 3, 4. So 8,640,000 cubic centimeters. 8,640,000 cubic centimeters. So if you want to know how many cubes each of 60 cubic centimeters, Now you take this volume, 8,640,000 cubic centimeters, you divide by this 60 cubic centimeters. Cubic centimeters will cancel, then this one will cancel this one, sorry, by 6 1 by 6 1, 26 3 for 24, then 24 3, then 1 2 3. So you are going to have 133,000 cubes of 60 cubic centimeters entering here. Very, very important that at the end of the day, you must write the units of what the question was asking. So the question was asking about how many cubes. So here, I do not need to see you writing centimeters cubed, but you rather write what the question asks you to do. So that's all about volume and cubes and cuboids. I now want to give you some work so that at least you practice and do something. But before then, I've just seen a question here that talks about something I don't touch. You are told the volume of a rectangular tank, the volume of a rectangular tank, the rectangular tank measures 360 cubic meters. That is the volume of that tank. It's a rectangular tank. What is the height of the tank? What is the height? So whatever is in question is the height. What is the height of the tank? If it has a square base. Listen, learner. This tank is a rectangular one, but it has a square base. What does that mean, learner? Remember what I said? If it's a cube, if the square is the base is a square, it means that the length and the width are the same. And so the question is a square base of 12. So this 12 is for this and this 12. So this measures 12 meters and this is also 12 meters. So don't just write 12 meters here alone. If it's a square base, it means that the length and the width are the same, 12, 12. So that is what we mean by square base. So the question is, what is the height of the tank? So volume will be equal to base area times height. We use that because we're talking about the base area here. A square base area. So the base area will be equal to, our volume is given, so you will say 360 is equals to, the base area is 12 times 12. That will give us the base area, 10 times height, because height is not given. So this is going to be 360 is equals to 144 h. Divide by 144, divide by 144. So you find that h, which is the height, is equals to, this is 360 over 144. So by 180 by 272. By 18 1 is 10, by 18 4. By 2 2 by 2 5. So this is going to be 2 enters here 2 times. So this is going to be 2.5. Our height is supposed to 2.5 meters. So height here is 2.5 meters. So that's how you're supposed to get land, 2.5 meters. If you multiply 144 times 2.5, it's supposed to give you 360. Let's just try it here. 144 times 2.5. Let's just do 25, and we know we have one decimal place somewhere. So this is 0, 20, that is 22, carry 2, 7. This is 8. This is 8 also. This is 2. 0, 0. 15, 16, carry 1, 3. One decimal place. So we remove that. So we remain with 360. So that's how it's simple. It's so simple, learner, that you can be able to calculate that question, those questions. So until next time, learner, I want to leave you with work. And wherever you get a problem, you come back to me and you'll be able to sort it out. So exercise 71 is our practice work. Exercise 71 on page 114 through 117. There is a lot of work there, but it's good for you to practice that way because it will give you a stamina to be able to do any question regarding body. So this is from number 1 to 17. 1 to 17. So if you do this work and do it well, you'll never have a problem about volume. Till next time, learner, I want to wish you well. Stay at home, sanitize, and be busy.